This afternoon we're going to be looking at just some of the kind of fun animation techniques that we used for transformation shots within Jonah. So we're looking at kind of like a basic slice rotation and offsetting that, creating quite dynamic effects. Looking at kind of like simple constraints and linking objects together and controlling things through points rather than through animating the geometry itself. And we'll be looking at playing around with Rayfire and understanding the parameters of that and how we did this kind of reverse wall fracture. And we'll be looking at an emerging particle flow system that we created and breaking down how that was made. And this will probably be one of the scene files we give you at the end. And then just a brief introduction to thinking particles and how we used it in a very simple way, setting up a kind of object materializing out of nowhere. I'm going to start us off with just by showing a few films which has really utilized some of these techniques that we've made in the past, and also then showing just some, we do quite a lot of testing, or I've done a lot of testing in the past anyway, just with different techniques and approaches to things, and it's really useful to kind of just generate lots of technique content when you're learning new bits of software and plugins and things like that. But we'll just wait for Jeff to come back in so he can kind of monitor the audio. And yeah, let's okay. I'm playing some audio from this film here. So this was a project I did in my master's, which utilized heavily the thinking particles technique that I'll be showing you. So the kind of tests I was talking about that really inform a lot of the kind of technique development. They start off very simple, testing different kind of fluid simulations and material properties and kind of the way that soft body systems work. And a lot of this is just tested. This particularly was in RealFlow. And just general, we do a lot of just general technique testing really. We try and kind of choose internal projects which turn our technique testing into something more. So it's not just for the sake of technique like it is here, but it's actually developing a project that we want to kind of explore within the studio, which happens to use different techniques that we haven't tried yet. But it's just being really active with kind of learning new things all the time. And what I'm kind of showing you this afternoon will be kind of a combination of lots of different kind of animation techniques, mainly within Max, using lots of different plugins and systems. And just to kind of give a kind of stronger library of different kind of animated assets at your disposal really when kind of coming to any kind of project. Specifically, a lot of the techniques are really suitable for animation within architectural visualization and transformation of buildings and elements of buildings, which seems to be quite popular. And a lot of the techniques I'll be showing are specifically relevant to how we made the street scene that we tracked earlier on today for Jonah. So again, we do lots of different technique testing using various different programs. We have another one here, which is focusing more on kind of particle effects. I'll turn the sound down. And this was basically produced while I was figuring out how to create the film Somewhere, the Golden Age Somewhere, the sequel to the one I just showed you. And that film was incredibly challenging. So there was a lot of different kind of concepts I wanted to try and show, and it was just finding the best kind of technical means of doing that really. I think that's the best way to kind of start projects. You shouldn't really do a project to explore a technique, but do a project to explore an idea and then find out which techniques are most appropriate. So I was looking at all sorts of crazy things at this point. I was looking at the resolution, like representing the resolution of kind of synthetic objects, and looking at how to kind of transform between a kind of like de-resed version of one object to another. Explored that in a really complex kind of setup, which was kind of linked to camera targets, which would kind of drive the transformation. That proved to be too heavy to even begin to render. I think the light cache just laughed at me for this one. So it lives in previous form. I was messing around with a lot of P-Flow sims and using Krakatoa and Fume effects, and how they can kind of work together. I was looking at using city generators like Ghost Town and playing around with those. Ghost Town's not the most reliable of kind of city generators. I think there's a few slightly better ones out there. But we haven't really explored them fully, to be honest. Combining all sorts of different things from Krakatoa, RealFlow, Fume effects, all together. Just really understanding the parameters of the tools that you've got at your disposal, really, is what I was trying to do here. And I was kind of linking particle flow systems to geometry. So this was in thinking particles. And then actually kind of linking the vertices of meshes to a kind of a wind-affected particle system within P-Flow, which created these quite dynamic animated effects which form the abstract towers within the film. And then again emitting particles from the vertices as well to give a kind of added effect. we got into some quite complex bits of animation or particle systems. And then again, similar to what we did this morning with the mocap data, but with a dog, a bone system. Because I wanted a kind of a dog in the film. But I wanted to kind of mess around with him. I didn't want him to just be a dog. I wanted to kind of be a kind of fabricated nano dog. So I kind of tried to figure out systems on how we could materialize from different things. And then there were some kind of happy accidents which kind of formed when the kind of skinning went wrong in the meshing of the dog, and he kind of like loses his head a little bit. But it has a really playful nature to it, and everyone quite liked it, as you can see here from everyone laughing. And so he actually made the final film. So we kind of left him in, and then so what we'll be looking at specifically are the animation of lots of the different components within Jonah. So we'll be playing with Mass Effects to see how this was created. Again, a lot of these things when you kind of show live are a little bit tricky, but we'll kind of play around and we'll have a look at all of these together. Hopefully we'll have kind of more of an interactive afternoon where we can kind of discuss some of the things that we're doing as we go. So a lot of this is a combination of manual and particle systems, basically. So, to kick us off, let's go into a new scene. Let's close this down. Look at this later on. We're looking at kind of one of the more basic techniques to begin with, but one that works, one that tends to work really well. And we use it all the time. It's really effective for kind of architectural animations, and it was really effective for the kind of some of the billboard animation that we did in Jonah. And it's we call it the slice rotation, and it is pretty much exactly that. You're slicing something and you're rotating it. So you can kind of see here that we have this billboard which kind of animates out using this simple slice rotation technique. So if we were to recreate this with a spline, with a plane rather, what you tend to do is you don't want to copy everything and create your kind of billboard or your object or your facade or your windows, whatever they happen to be, first. You want to kind of animate it first. So all we want to do is add a slice modifier. We want to do that while the object is kind of still flat, so that it it doesn't kind of warp, or if you've rotated the object off center, then your slice rotation might be in the wrong place. So you're removing the top here. But before you want to do that, start all of your animation on these things at 0. You don't want to kind of start anywhere else within the timeline. So if we enable auto key, put our kind of like first key, and then over 1 second, or quicker than that, we can rotate our object. And then if we slice at the same time, then what we've got is it kind of appearing. It's actually going the wrong way around, so we can just simply offset these keys to be the other way around, and then we've done it. correct way around. So within like 3 seconds, we've got our animation. So if we then copy this, turn our snaps on, if we copy this around, we can still have these as instances, as far as I'm aware. We can independently move keys of instances without affecting the object. So if we do that, we're kind of animating this separately. Now, what we did for this one is that we actually created one row, really. Nice. First one of the day. Probably because we've got 3 maxes open. I thought this machine might be able to handle it, but clearly not. So let's just open that again. Quite light file, so it's quite quick to open. But essentially, we kind of made this in panels. What? I'm going to cut this, Jeff. We made it in panels that go down. So we made it work as kind of strips, and then we copied those strips and offset them. We would have manually moved all of the keyframes for one strip, and then we only need to do it once, and then we kind of copy them all across, and then we've created our kind of effect once we offset. However, if we just work in a new scene, just forget this one for now, just in case it crashes again, and we'll work in a brand new scene for our element. Let's make this a slightly more sensible scale. Let's make this a meter by 0.3. There we go. Let's have it flat at first. So let's add our slice. Add a keyframe, the rotation, 20 frames. Let's rotate it forward. Also select our slice. And rather rotate it in position first. Okay, let's save this while we're here, so we can keep saving it. Let's activate our snaps. Let's copy this guy as an instance, say 20 times that way. And this would work if we wanted to kind of manually offset these guys one by one this way, and then we wanted to copy them up, and then we could kind of play with the offset of each of those groups. What's also kind of cool, if I just select all these and copy them up again, without kind of changing anything for now, is that now, you know, obviously now it's just going to do that quite simply. But there's a quite cool script that we use quite a lot. If I can find it on my thing, scripts. Okay, let's just go to script spots. It's called random rotation, or random select, sorry. This is really cool for a lot of different things that we might need. So look what we have here. Random selects. Say again?
There was a random piece of it.
Yeah. Not quite where we want. I thought I had it with me. Apologies. Definitely don't. Not going to spend ages looking for it.
Try looking for random select version 1. Maybe that's what it's called. Or DB1.
Let's have a look. Yeah, I think that's it, yeah. Thank you for someone in the audience there helping me out. So let's save link as. I'm not sure actually if it's Neil Blevins script was the.
You can just get rid of the space and it's on script.
Let's just drag this guy in. And then you can just select a random amount of objects in your viewport. And then we can just literally play with kind of like these keys so that we're moving and offsetting the animation. What we might need to do, however, is select the slice and make it unique, because otherwise we're only making the offset of the rotation of the object unique. We're not actually making the slice rotation technique unique. So we can keep the object as an instance, but not the slice, not the actual slice modifier. Let's move these guys, the ones we had selected, back. Random select. And then we can move things a bit more. And we did this for a few things. We did this for the rubbish scene in Jonah, where all the rubbish kind of piles on the scene on the beach. And what we used it for there was kind of to random select all of the rubbish and then offset the transparency of the rubbish so that it was kind of appearing. It kind of had a dappled effect to the appearance of it, and that meant that. It was kind of like flickering in almost. So if we go to the object properties, for that purpose, we animated the visibility from 0 to 1 over 1 keyframe for all of the rubbish, and then selected random select for however many objects were in the scene, 20%, 10%, whatever, and then kept doing that until we had a very natural kind of flickering effect appearing. So you can kind of keep going with this and offsetting things subtly to create quite cool animated effect. So yeah, that's quite a cool effect. So again, starting us off easy, that's quite an easy one, but it produces quite interesting varied effects, really good for facades and windows and things like that when you're kind of animating different things in the scene. Let's do a save on this. So looking at this next file, what this was a kind of manually constrained animated sign, which was kind of linked through dummies and point constraints and things like that, to give us this sign which kind of folds out of itself. And we use this in that street scene we just showed you. And the setup of these things are relatively simple. It's essentially kind of linking one object to the next, so that the animation or the scale of it is kind of like parented to its adjacent objects, but then also having fun with manual keyframing and linking things with points and dummies rather than actually animating the object itself. And the benefit of that is that you can kind of create an animation and then swap it out for different objects later on, or if you go into more detail later, which is, once you're in animation phase, is probably less likely, but it gives you that flexibility, and it's kind of a good way to work. So if we take a scene, we create some simple geometry. And what we can do is we can start linking and constraining things. Just get this out of transparency mode. There we go. If we select some points from the helper menu, we can kind of align that. Align it to our center and then just move it across over here to the bottom there. If we link our object to our point, then whatever we're doing to this object, to this point here, is going to animate through to the object. And it's much better than kind of changing the pivot points of your objects manually and then moving them and things like that. You can control exactly where your kind of constraints are and what you want to do with them, basically. You can kind of unlink your selection and move your object again, or your point again rather, and then relink. So what we can then do here, if we actually move this to, if we want everything to be constrained by this one guy here, if we actually just move the point to the other side, and then we animate this guy, say animate him 90. Then we also animate the scale from where that keyframe is to 100 to 0. Then we've created a movement like this, and everything is kind of constrained through the point. So let's just let's kill the rotation actually. Let's leave this guy just scaling. if we create another point, we copy this point, and we link the point to the object. I've got a funny issue with the scale there. There we go. Turn off our auto key so we don't get a funny scaling issue. And then we link our ball to the point. What we wanted to do, we want to create a chain. We can kind of offset that chain, and we can animate things in different ways, in different directions. We can have this ball doing something else. We can have it rotating, which will be then affecting these other guys at different times. So if we then link our object to this ball, but we then have this ball rotating after this point here, you can see how we're kind of creating a chain reaction of different things happening. And it's just through constraints and trying to use points and dummies as much as possible. And then you can have anything that you kind of pre-render or kind of bake out, you can kind of add to it, like we had cloth simulation and other elements kind of within that kind of sim and process. But as long as they're kind of linked and constrained through either dummies or to the other objects, then they'll still work within the simulation. So let's take this guy, and at this point, add a key here, and then over 10 frames, we're going to put another point. We'll copy one of these points over here. So actually what we'll do is link it over here. Link this point to there, unlink our box, and link him to the point. Still should be connected. And then we'll simply at this point rotate this point. What we probably will do is put the pivot point of this object in the center first of the ball before we link it, so that we can have the pivot point, this guy rotating around the surface of the ball. Let's do it roughly. And you can kind of see it's quite easy to create a kind of mechanical moving armature process with very simple constraints and scales. And you could animate the scale of these, you can offset the scale of these quite easily if you want to do that again, similar to how we did ours. Let's just click on the points. So we'll have from here to the second keyframe, we'll add a scale as well. So here it's 100%, but here it's 0%. Then we can have the same kind of effect happening. And again, the benefit of this obviously is that, you know, this can be a placeholder object for now when you're testing things, but then you can simply replace all of these things just by relinking a more detailed version of whatever this might be to the kind of point later on. So it's trying to not really animate any of the objects too much themselves, so that it gives you a bit more flexibility to change things later on. Kind of rotate, the scale on this probably doesn't work as well, but we could do other things. We could kind of animate more the position so that it's not intersecting with the ball. I'm going to get rid of the scale, I think. That's my point. I'm going to delete the keyframes of my scale. And I'll just continue this briefly. I think everyone gets the point. But the only difference, I guess, is we've kind of paid a bit more attention to the kind of like animation of this one. So we've got a bit more bounce to the kind of the overall structure. There's a few slice rotations or there's a few bend modifiers as well attached to some of the objects. But the principle is pretty similar, and it gives you quite an effective animation if you just simply have a bit of patience with having some fun with what you're creating, really. So let's just continue with this. So that's all scaling together, but this one definitely wants to scale out while this one's animating out. Again, animation 0, animation 100. And you can see we've kind of created this protruding arm kind of coming out, but then he's kind of not sure what to do at that point. So we actually want to link this guy to this middle one here instead, so that he's linked to this point, but then this point is linked to our kind of parent point over here. So although this kind of seems really basic and simple, you really do have to think and control how your points are kind of the hierarchy of your points and how they're working to kind of control your animation. See, he's actually rotating there, we might not want. So let's just continue with, let's finish this little animation we have here. And also sometimes you might actually want to get everything linked in a chain together and then kind of animate how that chain follows from the initial parent. So for example, let's just remove this animation scale. So let's basically create our points and link all this together first. So we want this linked to this, which it should be. We want this linked to, let's put it to that for now. We might change that later. Let's put this to that, this to that, and this to that. And then it's all kind of linked. And then at this point, kind of animates up, and it's kind of rotating around because of the order of which we've kind of done that. And we can then move around the keyframes, change the parenting. This is kind of intersecting, so we can kind of see how that's rotating and move it about. We might need to change the parent slightly. See what this guy is doing. He's rotating around that point there. We don't really want him to rotate, so we can kill that keyframe there. What we kind of want him to do is, at that point, maybe we had a keyframe here, and then he kind of folds in, so he might be more like this first. And again, the scale might be, if we go to the next point and rotate him in, and then at the same time animate the scale, or we could have put slice rotation, whatever we feel like. And we've created this kind of like arm that rotates, scales up, rotates, then our kind of, whatever that is, kind of pops out. Maybe it's a sign, in our case, kind of pops out. So although it kind of seems very simple to begin with, you can imagine just how complicated you can actually make these things. And then because you know that everything's linked with the points, you can swap geometry out later on, or you can feel like you're much more in control of the animation of these things. I think that's mainly the point, is that you can see what's linked to what, and you can know what to change and change the hierarchy of things if you want things to be slightly differently, rather than having to go into each of the objects, changing pivot points, moving things around in a complex way. You can actually start to create something quite complex from really basic principles. So let's save this guy. Okay. What I want to look at next is Rayfire. And just in the room here, how many people have used Rayfire before? A couple of people. Well, we can work through this together then. So basically, important thing to start off with your scenes is, you know, what scale are you working in? Make sure the kind of scale is correct. So let's kind of make a 10 meter by 5 meter or less than that. Let's make a wall. And let's just run through the basics of Rayfire first and understand exactly what the software's good points and limitations are, and also just run through some of the general problems that I've found with Rayfire over the years, and little ways where we can kind of hopefully avoid some issues, and we'll try and go through some of these problems. Obviously, Rayfire is very simply a fragmenting solution, really. So you can fragment your objects, and it also is built in with or kind of connected to Mass Effects or physics to essentially run simulations through. So you can not only fragment your geometry. Sometimes we use it simply to fragment, and then we kind of treat the simulation process slightly separately. Sometimes we kind of use everything within Rayfire and try and run it through there. And I think there are advantages and disadvantages between using different workflows. So let's give our scene a base material. So first thing you need to do is understand the general objects session here, and this is where you add your objects and set your material properties for those objects. So the dynamic impact objects, they're the objects that you want to actually break or fragment or act within that simulation with forces like gravity and collide with other objects. So if we add in our object here, and you can also then set the kind of material property for that object and the way that Rayfire cases that mesh to be able to run simulations from it. Because Rayfire will kind of create a simple version of the geometry to kind of like case within. And this is kind of set here. With a box, it's not going to really be a problem. But if you have a more complex object, then it can, it needs to be kind of simplified in the way that Rayfire skins that object for simulation. So if we actually just take a ball here and we create one thing to note if you want to do a Rayfire simulation is never use planes. Planes are not a real object in real life, and Rayfire treats it in the same way. It won't react to planes. Everything will have to be a physically solid closed mesh. So if you want a floor in your simulation, then it needs to be a box. It can't be a V-Ray plane or or anything like that. So let's create a simple scene. We have our floor and a wall and a ball. It's pretty obvious what we're going to do here. But just to kind of try and understand the parameters. So our wall, if we actually position him on the floor here and we have our ball, what we want to do is we want to add our floor to our static and kinematic objects. That's saying they take this into account, but don't actually involve it in the simulation. Don't actually make it react to gravity or react to or break or fragment or anything like that. That's only reserved for our objects here. Now, if we animate this ball going through our wall, oops. What's going to happen if we add this ball also to the simulation? We'll give them both. They're both by default is convex, porous, dense rock. But for these particular objects, is absolutely fine. So we don't really need to change much else. We can kind of tweak around with these are our kind of material presets here, and we can change the way that the default values of these work if we're not happy with them. But normally, otherwise, we can just select these materials here. So what we can do. What happens if we just sim this now? Let's go through some problem solving. So without fragmenting, without doing anything, let's go into our physics panel. And if we just press preview, what's going to happen? It's simply going to. If we preview and bake, our ball's just going to fall down from whatever height it's at, which isn't very high. So if we move him up, what happened to the animation of our ball that we had there? It kind of got overwrit by our simulation that we've kind of placed in. To kind of undo things in Rayfire, you have to go to Manager, Delete. To go back to our simulation, he says. Still animated. Now, because we've moved this ball up now, it's kind of overwritten what Rayfire has done. So if we kind of bake again, okay, so we've done some troubleshooting there. Sorry, you guys at home, but what happens there is that you would never really use Rayfire in the way that I just set up there. You would always just use Mass Effects on its own. you wouldn't really just load objects into Rayfire and then simulate them to drop down acting to gravity. You would only use Mass Effects. You only need Mass Effects for that. You don't need the kind of plugin for Rayfire to do those things. That's why there was not really any information to delete. So to kind of illustrate this, if we kind of fragment, and as soon as we press fragment, it's going to activate fragmentation for the objects that we have in our dynamic rollout here. And then if we bake that in, or if we fragment first, we can see that it's chopped up our object into a kind of Voronoi uniform method, and it's actually kind of stored our original objects. It's just hidden them away. So if we now go to simulate and bake, it's kind of taking our object. Our wall is kind of still standing because it's on the floor and nothing's really making it fall down. But then we've actually baked in our simple animation of our crumbling rock. Not looking super realistic yet, but I'll show you ways of improving that later on. But now when you go to Manage and Delete, it's going to delete not only the keyframes, but it's going to delete the animation of those additional objects, because it's not actually animating these objects here, it's animating the new objects that are created through the fragmentation. And this object still got the keyframes from our last simulation when we tried to use it in a Mass Effects way. So the original objects don't really get touched in the process of Rayfire. So if we wanted to animate this ball like we had a second ago, going through this wall, then what we'd need to do, if we just create a keyframe here as well, let's offset that animation to frame 20, say. Sometimes when you're animating things, you want to double check that there's no animation keys beyond 0, so you want to just go to a -5 and just check, because we see here that actually on frame -1 there's a key there, so we want to delete that. It's just a good practice to check your minus keyframes. So Rayfire by default is going to start on frame 0. However, our animation starts on frame 20. So in actual fact, we need to give this ball some kind of inertia, some kind of movement before we start our simulation. So actually, we want to start our simulation just before the ball hits the wall. So say frame 27. So what happens if we kind of, let's actually not smash the main object, let's only smash the wall into pieces. So if we go to our dynamic impact objects and we remove our sphere, and we delete it out, oops. Just clear and add in our box again. So let's fragment that box, that wall, in a very simple way for this purpose. And then let's add our sphere to our schematic objects. So it's going to react with the wall, but it's not going to break or fragment. And it's got the animation. So we're starting on frame 27. So what happens when we simulate now is bake. We're kind of using that initial inertia of the object. But however, now that we've fragmented that, what the ball is doing, it's not actually acting like it would do in reality. It's not falling down. It's just because it's a static object. It's reacting with the wall, but it's not actually then being part of the simulation itself. So that's fine if for some purposes. But now that we've actually fragmented that wall, we can actually do something else. So the fragmenting phase is always the first phase, but then what we actually want is for this sphere to actually be a dynamic object, but not fragment. So now we've fragmented it, automatically all those fragmented pieces are added to the impact object list. That happens automatically. So let's add our ball into the simulation now, because we don't want the ball to fracture, and we haven't enabled collision fractures yet. So now when we simulate, the ball is going to be part of that simulation using its initial inertia as a kind of starting point, which you wouldn't have been able to do if the ball was, if the simulation started before those keyframes for the initial movement of the ball was in place. So I'm quite happy with this simulation, say. It's all looking quite detailed. There's no errors. Sometimes you do get kind of like a lot of errors in Rayfire, but I'll go through a lot of different things with this plugin in a second. So the way that you can approach Rayfire, two different ways. Let's delete the simulation, which deletes all of our original kind of fragmentation, but can keep keyframes on our non-fragmented objects. So if we want to delete these keyframes, we have to manually go and delete them here. So there's another way that Rayfire can work. If we don't want to pre-fragment, we want to fragment on impact, then if we just kind of show this with a ball for now. So if we just kind of clear our list, add our ball in. So we've got our ball and our box. Our wall's not part of our simulation at this point. We don't want to pre-fragment. We want to fragment within the physics system. So we have to go to demolish geometry on. And this is hugely dependent on physical factors, so the scale of your objects, the material properties that you're using, things like that. So let's just start on 0. So our default material type for this is set as dense rock. We can change this to porous rock if we want to be slightly more kind of breakable. And then we have all these options here to be able to change the material to do what we want. But let's just have a quick test on how this works. So Rayfire impacts on, breaks up on impact. So originally those things weren't there, and then they're there on impact. And what we can do with that is add different layers and different probabilities on how they actually fragment. So if we delete that last simulation, and we say, we turn the depth level to 2, we can then do lots of different things, but let's just simulate this as it is at the moment. So you see now it's breaking once, and then it's breaking a second time when it feels like the impact is enough to break that material. And that's hugely dependent on, again, scale and your material presets. So you can see what that's doing there. Now, to kind of make this simulation a little bit better, I mean, we have a few things kind of popping around. It's not too bad, but if we wanted to kind of like make this slightly more accurate so that objects are colliding a bit more accurate, or they kind of come to a stop a little bit sooner, the settings within the physics system kind of add to that. And this is similar-ish to how physics works on its own, or Mass Effects works on its own. So we can change our collision tolerance. This will basically say between materials how close their kind of Rayfire mesh that it kind of puts around it allows them to kind of collide. So this is on 0.1 of a meter. Maybe we want to put this on 0.001, and that's going to be much more accurate. Might take a little bit longer to simulate. And then our sub-steps, again, this kind of setting is really dependent on what is happening or wrong with your scene. So sometimes 3 works fine. Sometimes you want to up this. And essentially what this is doing is how many times Rayfire is calculating your meshes between frames. So between frames 0 and 1, it's going to calculate 3 times. And we can kind of up this to, say, 7. You don't want to go much above 10 for these things. And sometimes the higher you go, actually it doesn't give you better results as you might think, because it's kind of overthinking each kind of calculation, and sometimes you just need a simple effect. So if we unbake this, and we also change because we've got two depth levels, we can change the probability of that second smash, so we can change that to 30% probability. We have minimum size limits here, which isn't quite accurate because the minimum size definitely is not 1 meter. So when we bake that now, there's less secondary collisions that are happening. But what we've got is, the first time we did this, we had objects kind of pinging out. They were almost by that initial impact, because they might have had a slight kind of intersection with their kind of like skin that Rayfire gives them. They might kind of have more of a kind of force that's kind of pushing them apart from each other. Because if these kind of invisible skins kind of at all intersect, then Rayfire tries to push them apart, and you can get some unwanted kind of like unwanted kind of effects of objects kind of pinging off and flying away in unnatural ways. So you can control that mainly with the collision tolerance and the substeps. A few of the settings while we're in this mode, if we delete that again, what we also have is gravity and timescale. This becomes really interesting because gravity, what they suggest is that you always work on a slightly lower than realistic gravity. One for reliability purposes, and that's what they say themselves. But also to create your simulations just looking slightly better. Often when you use this in absolute real time, I find it's a little bit fast, and lowering that to kind of 0.8 or even 0.7 can kind of give you better looking simulations. It's kind of a stylistic thing. Timescale is really interesting because what you can do is you can bake, pause, change that to 0.3. Let's extend our simulation to 200. And then continue the animation. So this is now generating a lot more keyframes for this simulation. Pause, and then let's stick this back on 1. Continue. Let's kind of stop it there. Hopefully that's done what we expect it to do. Yep. So you can see there, it's kind of, we probably want to extreme the effect a little bit, and let's also increase our time range to 200 in here. For the sake of speed, I'm going to adjust this to be back on 0.05 perhaps, and our substeps back on 3, so we can kind of illustrate this slightly better. Let's delete our frame. So let's bake this in, pause, turn this on 0.1, continue. So you can see that by changing our settings, we've actually created a different effect, which is not quite as reliable, I'd say. Extend our time frame. Also in Rayfire. And let's then continue the simulation. We didn't change it to back from 1. So essentially, you get the idea. It's kind of freeze framing more there, and then if we animated the time frame back up, it would kind of go back to time 1. And that's useful when you're doing kind of bullet time stuff, or you want to fly around the camera in a kind of dynamic way. You can really slow this down and play with the kind of time speeds of things. I'm going to do that again, just to kind of, I'm going to put the ball slightly higher, and I'm going to start it at maybe 5, 10. I'm going to increase this again because that was exploding slightly more than I want it to. Let's cancel this. My computer that's making that noise? It's interesting. It's pretty cool. I probably should try and save this and reopen it. Let's try that. Again, Rayfire has a kind of slightly unreliable element to it, really. It's an amazing plugin that is even used in all kinds of films. It's just that it's got such a limited amount of support, and in terms of the development of it, and it kind of gets developed a little bit every year, and it's made by a very small team. Okay, so let's load Rayfire again. Sphere in our box already linked. It remembers from last time. It's going to simulate. Bang. Oops, I cancelled instead of pause. Let's get ready to pause it. Pause. 0.05. Pause. Let's put it back on 1. Continue. And then let's just put a, see what that looks like first. So it really slows down on the impact and then speeds back up. And you can do a lot of different things with that and playing with different effects. It doesn't have to be smashing, fragmenting things. You can do all sorts of different things with Rayfire. The classic scene that everyone sets up is the kind of brick wall smashing, and that's again a very easy system to kind of set up. And you can kind of do that within Rayfire or Mass Effects. I guess Rayfire gives you the ability to then have additional fragmentation to your simulations, which might be preferable. So if we delete this, we just stop that simulation and delete what we did. What we can do is, if we want this object and this object to both be dynamic impact objects, but we want this object to smash and this object to not, we simply just have to make this ball a heavy metal, and this wall would be a porous rock. However, what we want is to be able to change these two elements here. think in this instance, this is where Mass Effects really is better than Rayfire, because this doesn't actually give you, I thought it did, but I was wrong, it doesn't actually give you individual control of the material. So what you'd have to do is pre-fracture the kind of wall first, and then have the ball smash through it, basically. But let me just confirm, because it really treats the kind of impact objects together, whereas what you can do in Mass Effects, which I'll show you later, is have individual control of what the objects are doing. So we'll see, this ball might not fragment, but we'll see what happens when we throw this ball at the surface. So we'll start the simulation there, or maybe just before. And we will allow demolished geometry on 2 levels. Got both our objects in here. So we'll try and bake this in now and see what happens. It is actually smashing the ball as well. So our option in that case is to pre-fracture our wall in the way that we want it to work. So if we stop this so we can see what's happening. It's quite a cool effect, but it kind of shows you what's happening. Once you've actually simulated it, it shows you what's been fractured and what's not been fractured. So there's no reason why we can't just create that first ourselves. So if we kind of like delete this simulation, and what we have the option for, which I quite like to use, is interactive selection in the menu. So basically, if we clear our menu and we have interactive selection set, whatever we're clicked on will be the object that we're kind of like fragmenting or simulating within the dynamic properties. So then here we can start to actually play with fragmenting this, and you can what I like to do is start big and then work in small. So we know that our impact object is there, so we can probably fragment these areas a bit more. Maybe turn this down again to give us slightly more control. Down again. Kind of have like a fall off fragmentation to the uniform. And there are lots of ways you can kind of control this. You control this with manually doing it like I'm doing here, and that's the kind of way I prefer to work. But just be aware that when you're doing this, you're actually hiding the objects that you're replacing with the fragmentation. There are options to not store the geometry when you fragment, but it's safer to leave them on and manually delete them when you're absolutely finished with what you're doing, because otherwise you won't be able to delete and go back. So let's kind of continue in here and adding a bit more detail. Around the impact point. Some tiny pieces in the middle bit there. So then what happens now is then we can clear our list, add everything apart from our floor to that list. Well, it's already on interactive selection, so we just have to make sure we're not on that, just to be safe. Selected that there, add them in there. static and chromatic. What we want to change is we don't want to turn on demolition now, because we don't want our ball to kind of demolish when it hits that wall. So let's bake this in and see what happens. Again, because we're starting on frame 39, there's no way that wall is going to fall down or fragment or break down before the ball hits it. And that's a way of kind of, if you're simulating something but you're finding that your objects are kind of falling before you want it to, then just change your start point or your start frame. So you can see now we're creating a much more interesting simulation, and our ball is not going to kind of fragment. And this, you can work in the model while it's kind of simulating, which is quite nice. But it's going to kind of focus on what you've got. So let's pause that. Have a look what that's doing. I think the hardware sharing options are only useful when you're working in small scenes like this. You can enable your ambient occlusion especially. Just to see what's going on in a bit more dynamic way in a simple scene. So that's working quite well. There's no huge anomalies, but let's just go through a few issues that I found that you might find if you ever use this software, mainly to do with the scaling of things. So let's stop this, and then we'll look at exactly what it's doing is that it's one by one deleting the fragmentation phases that we went through a second ago. So there's kind of a history to Rayfire within here. And it's going to basically delete our fragmentation objects in the way that we did it. And it's also going to unhide our kind of objects that we saw in our hidden list. And again, for non-fragmented objects, you have to manually delete the keyframes. Now, let's just have a look at some of the other parameters when we're working with objects that might be a different scale. So let's make a little box. We'll try and force a few problems the software has. Turn off our hardware shading. So this box is 0.2, 0.2, 0.1, quite a realistic size that we might want to kind of fragment. The problem is we're working in meters, which we always work in, and at this scale you probably should be working in centimeters. And Rayfire knows you probably should be working in centimeters. So if we kind of like clear our lists and add in our box, if we try and fragment this guy now, he's going to disappear. You know, why is that? And this used to drive me crazy. And essentially, within the fragmenting options, you've got a rollout bottom down here, and it's the size threshold. And this is essentially, it's on 0.2. So this is on 0.2 of a meter, and yet our object is only 0.2 or 0.1 even. So it's smaller than this. This is a 0.2 box size. So if we make this 0.001, fragment this again, then it's going to fragment properly. If we delete that and we put this on 0.05, okay, no, we've got everything. I know. Sometimes what you kind of get is some of them fragment or some of them disappear, and that becomes it becomes a bit weird. So if we put that on 0.1, fragment again, it's kind of handling this one okay. But sometimes it doesn't delete the whole box, but it deletes kind of portions of it because the scaling is wrong. So you can see here how it's kind of hidden, it's fragmented it, but it's kind of hidden this guy here because he's too small for what our limit is here. And unless you know about this size threshold thing, and then you can be pretty frustrated with your scenes that you find you spent ages building this model or whatever you want to do, and then you go to Rayfire and it seems to make half of your objects disappear. So this is the setting that kind of gets around that problem. So let's put him back on 0.01. And again, so everything is kind of quite realistically scale dependent. Now, I'll show you how we created the reverse wall fracture. So this is kind of a sample kind of breeze blocks that we kind of had, and nothing is kind of particularly happening right now. My time frame is on -10, so I can just check that the keyframes aren't actually being generated beforehand. I've got my boxes inside my dynamic simulation, and I've got my ground plane in my static. Now, we pre-fractured this because we didn't want we wanted lots of pieces flying up into place. We didn't want necessarily all the pieces to be on the ground and then they kind of form and then the whole objects emerge at the top. We wanted to see that fragmentation right at the top. So we did exactly the same process as before. We kind of fragmented our geometry. We pre-fragmented our geometry. And then we went in and actually added lots more detail to some of the areas. And again, that will be done by using the interactive selection. But what we'll actually do is we'll do what we did before. We'll clear this list. And sometimes you'll see what happens here. Again, it's another kind of problem solve, that because Rayfire animates the transparency of an object, then it sometimes doesn't bring that transparency back when you delete the simulation. That's again another bug that I found in certain scenes. So what we need to do is just select the objects, go into the material object properties, and then bring this back because the Rayfire has kind of not brought it back for us. So if we go to our fragments, one second. I mean, there's lots of different things we can kind of change here, which kind of affect the way that the kind of things fragment. We can try any of these things: wood splinters, you know, radial and uniform, irregular. You can change the way that the software is kind of cutting your objects up. And especially in this new one, you get lots of different elements like bricks and things like that. So you don't have to actually kind of model everything. You might be able to kind of do it in the fragmentation rather than building everything from scratch. So let's use the in the dynamic impact menu, let's use interactive selection. Let's clear our list. And then let's start to break this up as we want to. See how these other ones are kind of working. It's kind of more of an irregular kind of pattern, which works quite well. So we'll slightly reduce our iterations of that so we get a bit more control. And then we can start to specifically fragment some of these elements a bit more. So the ones at the bottom might not fragment more because they're, you know, they're kind of at the bottom. They're not being impacted much by anything, but the ones at the top might fragment a lot more. What we've got here is actually in this file, it's not actually hiding a lot of our objects. So let's just see if we can kind of find that checkbox for hide object, which was happening naturally in our other scene. This is clearly something that's been changed in this scene. Look at our fragments. Quickly check what happens when you simulate this, if those are actually active within the simulation. I've got a feeling they're going to be. If we just cancel this. So it's, again, we've got this error where it's cancelling our simulation and it's leaving us with our original geometry and the naught visibility. Let's pump these in again. Let's just do a quick simulation on this. We don't want any interactive demolition because we've already set our demolition. And we can see here nothing is happening. Why is nothing happening here? Because we have our interactive demolition still on. So we have to just quickly check that we don't have that on. And we add these elements again. Get rid of any keyframes that might randomly exist. So you can see what's happening there. It's kind of exploding away. This could be happening for a number of reasons. It's clearly because our objects are too close together and we have this very strange one of our problems is that our original geometry are still part of the simulation, so it's kind of exploding out of our original geometry, which we didn't have in the other scene. So my guess is that this kind of scene file, there's a checkbox somewhere which is allowing our original objects to somehow still be part of that simulation. Or at least, let's see if we can see. So I'm just going to quickly do a save as and load the scene again, just in case anything got corrupt. I think this is a good example of the unpredictability of this software, and again, what scene scale we're working in. So we're working in a decent scale. Let's open fracture test again. This is the smaller file. So let's just check that this is actually simulating. A bit too bouncy, and I think that's to do with this, both the scale we're working at. These are more accurate scale, but we can also go into the material properties and make things a little bit less bouncy, for example. Can I turn that right down? Because we're using this like Mass Effects, we've got no simulation. We need to delete all of our keyframes. Let's fragment these objects and bake in. So you can see again the slight kind of unpredictability of Rayfire sometimes, and it sometimes needs to be reset, and then it kind of simulates fine, and it also heavily depends on your scene scale. So let's kind of stop that there. So we have our wall, which is doing its thing, and all we did was selected all the points, select all the keyframes, and then with if this isn't there, then it will be in. Let's just have a quick deselect and right click. It's the show selection range. If you can't find this, when sometimes by default that's not on, and then you won't be able to kind of change the direction of your keyframes. So you have to make sure that configure show selection range is on, and then you've selected your keyframes. And then we just manually move this the other way. And then what we've got is this. And the reason why we've got this, like I was saying before, which is the reason why the other file had minus value, is because some of the keyframes pop up over here. So we have our original keyframe, and then we go to our final version keyframe, and then it reverts back to the original. So we want to delete this one here. So in our animation, we kind of created our wall. We pre-fractured the kind of area around the fish symbol. If we can remember, we'll go back to it. We'll see it in the component animation. So we'll skip to our wall. Exactly the same thing. We have a pile of rubble on the wall, pre-fractured, and then we kind of like controlling how that reappears. Combined with lots of other animation, it creates quite an interesting effect. So if we play this here now, we don't see anything until there. So it's the same, exactly the same effect, this kind of reverse kind of wall fracture effect. Now I was going to go on to Mass Effects, but was there any kind of questions around Rayfire before we kind of move on? Again, it's one of those kind of programs where you can do lots with it, but it can be a little bit frustrating with getting the consistency through files and through settings and through the scale. But I'm more than happy to kind of go through anything else with Rayfire if anyone has any specific questions on it, which I can try and answer. Nothing online? Take a drink of water. Okay, let's just ask the room, do we want to break now for 50 minutes, or do we want to break after we kind of cover some aspects of Mass Effects? How does everyone feel? Hands up for a break. 1. See you later.
Did you want a break?
I don't want a break, I'm fine. All right, cool. So let's just do a save as, just in case. So let's reset the scene. So let's look at how Rayfire's system differs from Mass Effects. Let's create some primitives, teapot. And we'll see this skinning process I was talking about slightly more obviously. So we've got a few primitives here. So to activate your Mass Effects toolbar, right click up the top and then select Mass Effects, and then now you've got your Mass Effects options here. Again, we dock it next to our layer and palette here. And it has a similar kind of feeling to Rayfire in the way that it uses gravity. The sub-steps and the solver are similar to the kind of like the detail settings to create more accurate simulations. Has a few other advanced features, such as multi-threading and hardware acceleration, which we kind of always want to check. we have kind of like animation kind of like sets here where we're kind of baking and previewing our simulation. And then we can unbake and unbake selected, which is kind of the same as the Rayfire's delete function within the top setting. And then this is for kind of editing materials once we've created a Mass Effects constraint. And then this is where we can kind of, again, adjust joint parameters and different kind of constraints that we put on things. So what we need to do is select our object and then select this button here, which is essentially selected as dynamic rigid body or kinetic body or static rigid body. So again, what we'll do is we'll, for the sake of argument, create this as a dynamic rigid body, and you'll see very visually what the skinning process of these things do. So you can see it's kind of like very haphazardly created a kind of optimized skin around this teapot, which will act as our kind of like mesh for our simulation. So we can change this, we can make this more detailed, we can create different sets. We can basically do that within the shape type. So by default, convex is going to give us this. Box is obviously going to give us this. That's the most optimized format. So sometimes we can, if we don't really care about objects getting too close to our thing and it's something in the distance, then we can kind of put a box around it and we can make it collide like that, but it will react as if it was a box in the simulation. For kind of more detailed elements, convex is fine, but what you often want to do is create a where are we here? Sorry. No, we want to create a. Give me 1 second. Okay, so we're back here. We've pulled out the menu slightly further so we could see what was going on. And what we wanted was concave, which we had on before, but we wanted to find the generate button, which is under the physical mesh parameters. So if I put this back on convex, you can see that it's kind of optimizing the mesh like that. But if we put it on concave and we generate the mesh, it will give us a slightly different mesh, which is more accurate to our original geometry. So this is really good because we can make our simulations much more accurate. And again, we can kind of give ourselves more detail. All vertices per hole, give us like 300. Generate again. It's going to kind of tighten our mesh further to be kind of skinned as much as possible around the object. So we can play around with these settings to kind of create a more accurate skinning. So again, we can do it to this object. Put it on concave mesh and generate, and it's going to give us our mesh inside. Again, for things like balls and other primitive, we can leave it on spherical for the ball, obviously, and on box for the box, and that'll be enough. So that's the difference in skinning, but the benefit, again, of Mass Effects is that you can kind of have different presets for each one. So you can have concrete for this one, for example. Kind of give this other one limestone, and you can kind of really control the physical parameters of things very separately. And again, you can kind of customize. You can give. Often this is a very limited preset, but you can kind of say, okay, I want to kind of I want something in between kind of cardboard and limestone, and you can kind of see what settings they have and kind of like try and optimize it yourself between what the presets here, or something a little bit more rigid than cardboard. Yeah, and then you can kind of go to none remember the settings from those presets and then type it in yourself and customize it to be whatever you want. So again, if we raise these objects up and then just simply start our simulation, they're automatically going to fall, but they are going to react to an invisible ground plane, which is kind of already there. And this is the setting that kind of comes within the environment, within scenes, use ground collisions, and we can alter the kind of ground height here. And if we have our own ground, then we can change that manually by unchecking ground collisions and then giving this a static rigid body. So now when we simulate, it should react to our object here. And this is just previewing. This isn't actually baking any keyframes onto the geometry. This is just essentially, just previewing our scene. So whenever we rotate back, we're not actually doing anything. We're not baking any keyframes. So reset the simulation. If we wanted to add keyframes, obviously we just bake all. And then it's kind of baked within our scene. Again, the reason why that's going really slowly is because we've created a very large surface, a very large objects. So it's going to react like it was very large. It's going to react like it was a kind of object of 50 meters falling down. So again, it's very important to kind of get the scale of your scene working right. Now, what I want to kind of go through actually is the way that we did the trailer at the beginning. And it's kind of about, this kind of discusses quite a lot about the sequence of the way that you bake things and the fact that you can run simulations after simulations after simulations and create very detailed effects. And one of the ways of doing this is to not simulate everything in one go. So for example, this wasn't all one kind of long big simulation that kind of we pressed play on and then it worked. It was kind of simulating it step by step. So if we create a kind of simplified version of this, if we go to our top viewport, so if we create something of a similar-ish scale, and obviously looking at that cart, it's very detailed. So we essentially had a detailed and a simplified version of that cart. And the simplified version was linked in the same way that we were linking geometry earlier on. Or that rather the complicated version was linked to the simplified version, and then we simulated using the simplified version. So we weren't simulating with crates as detailed as that, or kind of tubes as detailed as that. We were simulating with box geometry around those elements to then create a much faster simulation. And that's what you don't want to kind of create these super detailed models and then try and simulate with them. You want to create kind of optimized versions of them. It's just like in game design when they have a detailed version for render, but then actually underneath the skin of a lot of games, you have the kind of simplified collision geometry that is used to kind of interact with the scene. But you don't actually see any of that. Let's create this object. Not create it instanced. So we'll have our loose base of our trailer. Make sure that nothing is intersecting too much. Now, this loose base wasn't simulated. This loose base was, we created a trailer rig which then worked like a car, so the wheels spinned automatically. So we tracked the back of the bike using geometry tracking, and then we attached our trailer to to a back end of the bike, which then pulled our trailer in a kind of simulated way. But that wasn't using Mass Effects. What we then used Mass Effects for was initially animating these casings within that trailer, and then on a secondary level we animated the oranges and these kind of elements within those containers. So if we group this, and we kind of animate it manually as if it was our trailer rig, we'll give it some other movement so it's not just going straight forward. Can maybe lift it up a little bit for the sake of effect. Just kind of twist it around a bit. Give it a little bit more movement. Might be too much, but we'll see. Interesting to see what happens. We want to keep our containers in there. We don't want them to fly out because we want a secondary level of animation to happen within within those containers. So let's just see if that seems about right to play with. So now let's create our box, let's lift these up a little bit, give it some extra room. And we'll plonk these inside. Give it a bit of room to move about. Make sure that it's not intersecting in our surface. Start it off above. So let's render 4 of these inside here, or rather simulate 4 of these inside here. Actually, before we copy these, let's just skin this now, so we have the same skinning parameter on all 4. So then if we change the parameters, it will change on all 4 as well at the same time. It will be an instance. So if we kind of add a dynamic rigid body, change this to concave, generate the mesh. Let's just add a few more into here. Let's just double check. So this is why there was another one, which is supposed to be slightly different. There definitely is one missing from here, from the one I've used before. It's on custom. I don't think it's actually skinned it to the mesh, but let's just have a quick test if we drop something inside of it, just to have a look, see where the limitations of that box are, because they might have just updated it. So make that dynamic. We'll change this to static, and we'll just see if that object can fall down into that box. Nope. So let's just double check. Change that to chromatic, dynamic. I don't think it's generated the proper holes for this. Again, this is different. Should be able to pick mesh, at least. Okay, seems to have worked there. With improved fitting on. This selection wasn't there in my previous version that I was using Mass Effect, so apologies for that. But you should, again, concave should be the one where you can connect, you can kind of correct any kind of skin with any kind of object, really. But they've just slightly changed the physical mesh parameters, so it's just getting used to the min size, the mesh detail, and the max vertices, and then whether this option for improved fitting works or not. But it seems to work in this case, so let's just check if it does work in our simulation. Yeah. So now we have a successful hole created for this box. So let's go out of isolation. So what we want to do is this group, we'll do the same thing, but I think we'll open the group and we'll apply the settings separately. We don't really want to apply the settings to the group. So we'll just select everything. They're simple boxes, so it should be relatively straightforward. And then go to select chromatic. So they are moving, they're not static, but they're not to be simulated with dynamic settings. Did we add that to it? Let's try again. It's not liking setting them all together. Set them as edit poly. This is interesting, isn't it? Yeah. Suggestion here from the group that it might be the group, so we can try deleting that group. Yep, success. Give that guy a gold star. So where did we added that to this one here? Let's just do them all together so we have the same settings. Chromatic rigid body. It's got the box mapping, which is fine. And then we'll delete him from our simulation. He's chromatic. We want him to actually be dynamic instead. Let's just do a test here to see how this is working. It's intersecting. Now we've lost the animation for our objects because they were part of the group. So we need to do a few things. First of all, let's just raise him slightly more for the initial solve, and then we'll try and add some detail to our settings. And then let's just reanimate our object, which was a group. add a little bit of rotation to this to kind of try and get some movement for our interactive objects. Should be enough. That initial bit's quite fast, but we'll see. It seems to be kind of stuck inside our simulation. We haven't baked anything, obviously, so let's just increase our settings slightly. Let's turn our sub steps up to 7. What we can also do is within the setting for the hulls, we can kind of manually change the way that the hull is kind of reacting. So if we want to kind of change the position of the skin, we can. And the reason why you'd want to do that is if you wanted to, if you were having objects which were kind of seemingly floating above each other or seemingly intersecting, and you might want to either increase or decrease this the size of the hulls on these, basically, and that should be instance for all of these. So let's also increase the amount of points in here to see if that makes a difference. Just raise him up so he's a bit more obviously away from the surface at the start of the simulation to allow him to naturally fall down. Let's try to bake it in and let's see what happens. He's kind of flying away. So it is a dark art. If we unbake all, convex hull is working. Let's have a look at this setting here. Let's give him a preset. Might help give him some, make him kind of concrete. Make him steel. What I might try if this doesn't work is making the original, all of these objects one mesh. Annoyingly, we still have our animation, but we are going to lose that again because we have got to reapply our rigid body. Let's try and, it's not that good practice, but for the sake of speed, let's try and make this on here, which it hasn't really liked. So we'll undo that. Copy these keyframes. You can't really copy the keyframes. We'll make sure that the system works before we do any kind of complex animation for the trailer. generate the holes for this, which is giving it more side holes now, which is good. Don't really need to improve the fitting, but we'll do that. Give it steel. And it's not liking our object one bit. Let's just see why. See, it hasn't generated the holes properly there, so that's why. So although it looks like it did, it really didn't. So we want to really be careful with how these things are generated. So we'll try this again just to see. Still not doing it. So you can see that going across there. As soon as we bake this in, this object is becoming not what we expected at all. It's automatically changing back to a convex mesh. Which it shouldn't do. See how it's changing there. So it's got the holes in place there. Let's just delete this and start again. If you haven't got the script attached elements, it's useful. Also, what we can also do just to make sure everything's back where it should be, just add a X form, kind of reset the mesh, and then let's apply these again and just see if we can get this working more consistently. What I actually think might be happening is the ground plane. Let's just check that. No. Okay. It's not seeing that object at all, and it's just reacting to the ground plane. So we need to figure out why. So let's just put this on static and see if that's reacting to that. Is very strange. So again, the risks you run of doing something as technical as this in your live presentation without the comfort of your own home and computer. Okay, so let's just have a look at why this isn't working. This is pretty strange. This is quite a basic simulation, so it should be more than fine to set this up.
Could the normals be flipped? Would that affect it?
Yeah, we can suggestion there from the crowd that the normals might be flipped, so we can try that. Don't think so. let's figure this out together. It's good to problem solve so we don't run into these problems when you're doing it yourself. Yeah, I've never had something not react to the scene like this, so let's just create a new mesh for some reason. Let's try this. Do the same process again. And it just doesn't like it at all. It could be our object that we're trying to dynamically sim. So let's just try another object with our ground plane just to check. So it is clearly this object here which is causing the problems, and again for me it's because of the lack of the setting that I was used to within here. So let's try and really resolve this in the new Mass Effects. Because it doesn't like the fact that you're kind of curving within this as a shape. I think the way that we approached the box was to actually model the faces separately, if I can remember, which we could do that. So we're not reliant on a kind of like closed undulating shape like this. We should be able to do that, which is the reason why I'm kind of being persistent, because we should be able to create a hull which kind of cuts within that shape. And it is something I've done many times before with a slightly different setting within here. We have original and other settings within here which gives us options to use both the original mesh as well as a kind of custom generated hull for where the faces are for the model, but we don't seem to have that in here, even when we kind of click options, which gives us something that might be similar. But I think what we'll do is we'll basically move on with the secondary approach, which is to select and create the object separately, which means that we don't have to create a complex hull for the object. And if I do find out what that problem was after this recording, then I'll make sure I get that in there for the download once I'm more familiar with the newer Mass Effects. So let's just create this box again. Now I'm thinking about it, I kind of think more and more that we did do this for our box. As the audience say, yeah, yeah. The main point of this tutorial is to go through the fact that you can simulate things separately and baking them in and then simulating again. So you're kind of converting one thing from a dynamic to a chromatic simulation once it's been baked in. So I really want to try and get this illustrated visually. So if we create this as a dynamic rigid body, which is going to cause us a few problems, but because these are separate objects, we now need to group them by attaching everything together. That way it can create individual hulls, simple box hulls, but it will act as one object. It's not going to kind of fall apart at the seams. If we left this as individual objects, then we wouldn't be able to do that. I'm still not trusting this new system here at all. Move this aside. So it's still treating this, it's not mapping this completely separately. Let's just double try this, just to see if it falls in. The thing is, we created that hole, and the other box did fall inside it. So it's a mystery to me why that didn't work, to be quite frank. But we'll try it again. Thank you. We had that previously. If we make this a static while we schematic while we wait, let's just bake that in. Make sure that it is working, which it seems to be. But we had that before, so let's just see that if we turn this to dynamic now, that it does fall within our objects. Which it still does not. So we haven't added our schematic to our base. Okay, so we're finally there after much trial and tribulation. But again, it just shows that however many times you do these things, as soon as you plug in a projector and a live audience, things slightly change. So this seems to be working now. We've rebuilt our box. I don't think we necessarily had to do that. I'm going to be a little bit stubborn and try this again, just because I'm not too sure why this wouldn't work. Again, I think it's slightly strange that they've changed the system in here, because they had a really bulletproof system before. Which isn't quite working, and that seems to have done the same job, but then we had problems with this intersecting. But let's just have another go with that. So it's very strange, as you can see here, the difference between a very standard mesh at the bottom as our collision object, and this object here we've got on concave, which seems to have the right holes and everything kind of set, which is just not wanting to interact with our other object at all. So by solving that, we've kind of made a simpler object with boxes. But it would be nice if we could be able to do that, because in life we can't recreate this for every object that we might want to do. So again, I am going to look at that at some point, but for now, for this tutorial, let's proceed with from our box here. So again, our cart with all the fruit and all of the kind of like signs within it, and we could set that as one simulation. But for this especially, we had quite a few objects which were simulating within these boxes. So we didn't want to necessarily run that as one sim. So it gives us a lot more control if we first unbake our selection and reset. If we first kind of animate our cart, which we had as a trailer rig. Do it simply. We then copy a few of our dudes around. And we should now be able to simulate this as we would expect. So let's just bake it and it's a small animation, so it should be fine. So we can see now we've created our active simulation with our carts. What I'll do, just for the sake of viewing, I'll create a camera in the scene so we can follow this. And I'll constrain both the target and the camera to the main box, so that we can look at this a bit more objectively through our camera and see what our simulation is doing. I think we could probably make this a bit more extreme, especially when we add our secondary elements later on. So if we go back to our Mass Effects options, and we unbake all and reset everything, so we've got no animation apart from our main thing here. So let's go to the keyframes, and let's just add a bit more rotation to this to make it a little bit more dynamic. And we'll see our camera move as well, which is fine. Try and get a bit more movement so we can maybe chuck some stuff out of these things when we start simulating the secondary elements. Let's bake all again. I still think we could push this a bit more. Let's just maybe get right over there. Have some fun with these things popping out. Let's unbake all and reset. Go into our camera. There's a bit more going on in there now. So then we'll kind of go back to the beginning, create all of our oranges. Let's give these a dynamic rigid body, but because these are baked in, that movement's baked in now, those keyframes are baked in. So we can change them from a dynamic rigid body to a chromatic rigid body. So we don't have to use the Mass Effects toolbar anymore because we've baked in all of that animation for these objects, so we can kind of delete those. And then add it again as a chromatic rigid body. We still want to change these to concave, hull, and generate the mesh. Take our oranges, which are dynamic, can make it sphere, which will be a little bit more optimized than the default for this type of object, obviously. We can kind of place them within. So let's just kind of copy loads in here and see what we can get away with. See if instancing works on here. Because dynamic rigid bodies take a lot more kind of effort for Mass Effects to kind of figure out, and it's going to take a lot longer to simulate if you tried this all in one go. And it's just better to kind of bake everything in and do it in stages. So if we just try this now. You can see that our objects drop in and they start to actually fly around in our scene. Which is exactly what we get So we kind of got there in the end. And I think it's good to, slightly stressful, but good to go through how things kind of work and what limitations are in the software. But let's just delete all these keyframes of our apples, which are now apples. Or unbake all rather, let's unbake all. Just as it was going so well. Let's just manually delete these keyframes. Let's just copy them around. Nice. Let's delete these mass effects. Okay, let's just try and save. Take a break after this one, and then we'll talk about some of the other particle effects and once we're finished. But I would like to get this working. We seem to be copying things, but it's not actually visible in our viewport, which is strange, unless it's on top, which it seems to be. So we've got some kind of lock on our geometry here. Let's just go back in our history. Nope. Okay, I'm just going to restart Max, because it seems to have some viewport problems. This is slightly weird. Unless there's any keyframes on before 0, which there's not. Okay, so reset that again. There's something very strange that's kind of happened here when we're trying to move objects. Getting that kind of, do you ever get that in Max where you're kind of moving something and then it moves loads? I get that a lot. We probably should have cut when that was actually working, and now we can't move any of our geometry, and I think we'll probably cut the video there, Jeff, just to let you know. Yeah, this seems to have happened a little bit strange. Let's just select all of these, add a reset X form, collapse all to edit poly, try and get some control back of these things. Say again? Yeah, there's a, because when we were copying them a second ago, they were actually copying, but you can't actually move them. There's some kind of weird lock on the position of these things, but not the scale. What I think we'll do, let's just try. Yeah, there's something gone very strange in this file, where we're moving objects and it's kind of reacting in a very strange way. So we're going to definitely leave this file. But we achieved what we tried to achieve before we reset that there with our kind of apples or oranges or whatever you want, and communicating the concept of the stages to baking out simulations, so you're not doing everything in one go. So we'll take a 15-minute break there, and then we'll kind of finish off the day with some cool particle stuff. Okay, so we're back on here, and we did finish our simulation. So you can see when we play this, we have our apples inside, and they're reacting nicely to our crates inside. They're reacting to the ground plane, and they're reacting to our kind of cart base shape there. And then just to kind of, we had a few questions in the break which I'd like to share regarding some of the other details of this cart. And essentially, once we had built the cart, we created another mesh within the middle, which acted as our banner, our poster, a kind of vinyl banner, which is kind of pinned in different areas. And essentially, this was a very simple cloth sim. And what this was that we kind of constrained lots of different point helpers to our base mesh, which then kind of moves with our cart. And then we simply created groups and nodes within our cloth simulation to kind of be constrained and pinned by those points at several different areas around our mesh here. And then we had a wind pushing in this direction, which was again constrained and linked to our main mesh, so it was moving in the same direction, and that gave us our kind of flow. And then when it was simulated, it gave it this kind of constrained wind blowing effect, basically. So that was done in a simple cloth sim, constraining points to the base mesh, and then creating nodes within the cloth sim to attach vertices of this mesh onto those points, basically. So you're constraining the points to the mesh, and then you're constraining the vertices of the poster to those points. And then with the wind effect, you create quite a realistic mesh, which is kind of taut. So I'm going to save this, and then I'm going to open up a few other files, which is using, again, two other kind of particle systems within Max. One is a kind of feature which is now built into Max. It used to be a plugin called Box 2 and 3, which is a P-Flow plugins. But now in 2014, it's kind of part of the base settings within P-Flow. And what this effect is essentially merging or kind of like appearing out of nowhere geometry from which is being used as particles within P-Flow. And the way that we use this effect was for the girls sign in, again, this street scene. So if we kind of rotate this here, we get to this scene here where our kind of sign materializes in with three different material values, from a kind of mesh to a kind of metal, and then to a kind of like a cladded kind of rusted effect here. So if we dare to, we can open two Maxes, close down this so we don't save on memory. And we can open up that girl sign specifically. And this is the kind of this was the kind of testing scene where we kind of developed the technique. And then we used that technique to plug in other bits of geometry. And I won't be building this from scratch in this file, but I will be explaining how this was built by looking at the tree. And then this is, again, one of the scene files that we'll be giving you to kind of explore yourself. Because we found that once we've set it up, it's very easy to kind of change parameters and also to then load in different bits of geometry instead of the placeholder ones we've got here. Let's just create our default lighting. Default. So while we're waiting for that Max to load, let's just change our lighting to default. Let's have a look at this P-Flow tree. How familiar are the group with P-Flow in general? Does anyone use P-Flow for anything? Use a bit of P-Flow. So again, P-Flow is a really fantastic system in Max, which works as a node-based operator, and essentially allows us to create different events that have different effects at different times to our scene. So if we load the final girl's sign, we can see how the final effect of that. And essentially, you can use the starting point for this is any piece of your geometry. So what you're essentially going to want to do is the test file that we created was manually kind of making lots of boxes and snapping them together, and then we use those as the kind of base for kind of testing this technique. But in actual fact, what we in reality want to do is kind of have an existing object, or building, or face, or head, or whatever it might be. In our case, it was these signs, and then kind of fragment it to kind of produce this effect. Now, there's lots of different methods you can use. You could use Rayfire, that we've just seen. You can fragment stuff in Rayfire. There's a really great plugin called Constructor. Let's try and find this. Which we will locate somewhere. That's the same kind of Voronoi fragmentation as Rayfire. Well, I'll locate the constructor plugin while we work. But essentially, if we take a look at this P-flow operation, we're trying to understand exactly how it works. So we have our we always have a kind of at the top of the tree our render of our base geometry. Essentially, this was kind of born out of a birth group, and from this birth group, we can add in all of our kind of elements. So once we've kind of fragmented our object, whatever it might be, we kind of like add those into the kind of birth group. And again, if you're the kind of detached elements or detached faces kind of comes in quite handy here. If you've got a kind of teapot, for example, everyone likes doing teapots for their tests, and you use the detached faces operation, we can kind of like collapse this to poly, select all of our faces, detach all. And this would be a simple method if we don't want to use Rayfire or Constructor or anything like that. We can just attach all of our faces and then shell on the inside the objects, change the pivot points to be in the center of each of the objects. And then we can use these for our kind of build up, and we can kind of naturally build this teapot or our structure in a similar way. But for this test, we've simplified it, and we've got just the boxes for speed, because this can be quite a complex and quite a heavy system once it's kind of fully in place, and you really kind of have to develop the base script first on a kind of like low res geometry before you really get into anything more complicated. So we have our birth group. We are attaching all of our elements. And then essentially what we want to do is at a certain point we want to kind of create a new test operator of a collision, and then from that collision we then load in our deflector, and this deflector can be anything, but in this case it's a actual deflector. You could have used a plane or anything else, but just as a kind of a catalyst for the kind of change that you want to happen in this system. So we could ignore this for now because we do these two processes later on. But essentially, first we want a birth group, a collision, and then we want to do something into that from that collision. So once this collides, what we want to do is we want to scale. So that's what we're doing here. We're kind of scaling the geometry. We're kind of pushing them apart with the kind of keep apart node, and we can kind of like play with how this reacts. We can change the setting of this. So that's what's great about this system is that once you've kind of set it up, you can not only change the objects, but you can very easily change all of the settings within it. So we've got a keep apart, we've got a rotation, random 3D, and then we've got, this happens slightly later, we kind of having a second test, where basically this is where the kind of data operators come in, and data operators are a little bit more complex system within P-Flow. But essentially what we're trying to do in this system is we're trying to say, okay, at this point, it's going to fly out through this catalyst, and then over a certain period of time, say 48 frames, or even define target 2, which is here on, let's just delete these, sorry. Oops. We want the system to return back to its original shape, return back to the position. So we're animating from a 0 to 1 scale initially. We're then rotating, we're then transforming the value of that scale, and then we're returning back to the original position in this one. So what this data operator does in this first birth group is it's essentially storing the initial point of where these cubes are. So if we go into that data flow, we break it apart, we can see that we've got two append operators. So we've got a input vector, which is storing the position, and we're outputting that to a script vector. And then we're just saying that this should be new in the event. So when we kind of collide these, we don't need to do this. This is just a visual thing when you're creating these data operator sets. But we're essentially telling it to store the position of our objects in this event, in event 1, and we're kind of storing that as a script vector. And the reason why we have to do that is because when we then come back to finding our actual position of our objects, we have to select, just rotate through here. We have to select point by script vector in the option here, basically. So you can follow by target. There's lots of different options. P-Flow has kind of an infinite array of kind of options, but essentially what we're doing is we're creating this data operator set where we're storing the script vector for the position, and then we're kind of like telling it after it's kind of moved around and done different things, and we've put rotation, keep apart, all different things within there, but you can put whatever you want within this data set, within this event here, and then after a certain period of time, we're telling it to return back to its original position. So we have born and store the position. We have transform, rotate, and scale if we want. Then we have finding back to our original position, and then we just have a stop. And that stop just stops dead the position of our particles, because without that, this find target operator would initially find the location for our particles, but it would then keep flying out using the inertia of the animation for the particles. So with this system, which kind of looks a little bit intimidating if you don't know P-Flow and sounds a little bit strange when I'm trying to explain it, but it is actually it's making a lot of sense when you just consider these as separate elements rather than lots of different complicated nodes, basically. So born, rotate, scale, find target, and then stop. So it's not actually that complicated. The mainly complicated thing was understanding the how to store the position of your particles using this data set here. So we can kind of continue to mess around with how these things work and change, and we can edit the objects. And in our version that we did, we had lots of different sets developed in the same way, So again, this looks even more kind of intimidating, but essentially it's just the same thing. And all that's different is that these, in each of the systems, these deflectors are kind of offset in their animation. So we can see here that the keyframes down here that are offset by I think about 5 or 10 frames on each one, so that the collision test operator only starts when that deflector goes through that system. And by offsetting it, you can create this quite dynamic kind of like appearance of this kind of girl sign here, which we did. And we've used this since in other applications as well, because again, once the kind of initial R&D was done on creating this this system, then it's very easy to kind of replicate and swap out, because we have different different objects attached within each of these data sets, but everything else is more or less exactly the same. So again, I think with this one, it would have taken too long to do this live in the class, but the benefit of this is that we're giving this away within the set, so you can actually go with this file, pick apart what everything is doing, and you can kind of understand it for yourself and try and understand what the scale and the keep apart and the go to rotation, what their purpose is for each thing. So again, once you kind of get a bit more familiar with some of the aspects of P-Flow here, then it will be a lot more obvious of what's going on, and it's actually not that complicated. So what I also want to show you is a really cool effect that we used in the Golden Age film. And this is the using thinking particles. And I'll open up both scenes to kind of introduce you to thinking particles. So I'll just hide this for a second. Thinking particles is found within particles thinking when you install it. And again, this was a native Cinema 4D plugin before a few years ago it became a plugin available for other applications. It's extremely powerful, much more powerful than P-Flow. I only know the surface of this program, but I already know how useful it could be. And I'm kind of waiting for a project which justifies learning it a lot more. But essentially, it gives us a kind of window, not too dissimilar from P-Flow, but all of our menus are kind of hidden. We've essentially got our master system up the top, which is essentially where we add our groups and we organize our file. With simple scenes, we don't really need to do much of this because we can have everything all on one layer on all. Our master dynamic set, which is essentially where we add all of our nodes and parameters. And then on the right here, we have our where most of the settings are for the scene. So the basic thing we want to do is create a new dynamic set, and this will open a new window here. This is where we essentially build our nodes and add different things. So we can add all sorts of things. I'll be showing you something very specific, but just as a general kind of starting point, we can start with a, let's have a look here. Position born. And this will be a standard particle flow system that we can generate, which is, again, we can do this in multiple different kind of programs and settings and things like that, but it's not going to perhaps react in the same way. Thinking Particles has a really good feedback with the viewport that some of the other particle systems are not quite optimized. P-Flow, for example, has been around for donkey's years, but it's kind of been written by one guy, and it kind of has been updated with the new sets with 2014 with Box 2 and 3, for example, but it's not really been pushed and developed by Autodesk at all, whereas things like things like Thinking Particles are being pushed a lot more, and their kind of technology seems to be a lot more developed, basically. So if we look at this, this simple setup here and what we have, and we've got just a really simple kind of birth operator, the position born. And all we've done is we've kind of created a count of 162 particles streaming out of this system here. So that's essentially the most basic particle flow system you'll get. But why I wanted to show you this rather than straight away going to the example that we've made with the kind of fragmented transformation effect was I wanted to illustrate how it kind of can be combined with frost and introducing you to frost very quickly. So let's unhide our, or let's just add our frost node in, another one. We've hidden our other one. So as soon as we click on frost up here, it's going to mesh automatically what we've got attached to it, and that'll be we can add P-flow, we can add thinking particles, and we can even add real flow meshes and things like that. And the way we use frost mainly is either for meshing particles like this that we want to have completely in control in Max, or the way we've done it is when we've done a real flow sim and we've kind of generated our base mesh, our splash and foam particles separately, and we want to mesh them slightly differently, and we want to have that control within 3D Max rather than having to stick with what we export from real flow. So this gives us a huge amount of control, and when you're doing kind of splash and foam on base meshes, you normally kind of work with different materials on each set. So you'll have the base mesh as kind of a water material, you'll have the kind of splash and foam as a slightly more opaque white material, and that will give you a kind of the kind of splash and foam effect when you're rendering. So anyway, we've got lots of settings we can kind of mess about in here. So we can kind of add more particle effects. With here we can see our thinking particles is linked here. We can change the way that the object is meshing by going to the meshing parameters and changing this to geometry. We can change this to be any kind of object we want, but it's currently set to plane. We can custom pick our own geometry. We can select box. So we have a kind of a particle emitting a box, which could be quite a cool effect. We can do so much with simple meshing parameters within Frost. Let's have a look what else we can do here. We can change the scale of our geometry. Let's just have a look at the scale parameters. You can sync this by time or lifespan. You can have them grow over time or born at a certain size and they kind of fade. They fade. So we can play with all sorts of different parameters. Randomize radius by ID. So it's really worth having a play with Frost and see what it can do. We can also change it to anisotropic, where we can kind of replicate more of a kind of relaxed mesh effect. And again, that's going to be useful when we're kind of trying to recreate water or anything like that. And we can kind of refine and change the kind of like resolution of this mesh in both the render and in the viewport. So we can kind of say, okay, the viewport we want it to be that resolution, but then in the kind of render we might want it to be that. Once we've set that, we can just check that back on 1 and render at 5. Again, we can kind of like refine our vertexes. There's lots of different settings to kind of play around with to create a realistic mesh, and each of these have different kind of settings. So let's have a look here. So this is one that's often used for water effects and things like that, and it kind of you can get a lot of control over how the object is smoothed and how the kind of metaballs are working together. This is obviously quite a not very detailed particle export, so you can see that we've kind of got quite globally effect with the skinning. But we can see that we can automatically control how those kind of globules are are working. And this one is more commonly used for when we export real flow particles. We'll use the Zbrush and meshing technique. And essentially that's all Frost is. There's nothing more to it than that. It's just a mesher for particles, and you can do different things with it basically. So a few of you had been asking initially about the how some of the, let's just move this slightly out of my way. How some of the assets were created for the town, some of the more holographic elements. Well, ones like this, for example, they were done with Krakatoa and Frost. So again, Krakatoa just generated the particles based on a kind of mesh that we'd created. So we just said fill mesh, and then we used Frost to then represent those particles as kind of cubes. And this was, yeah, again, very simple. And we did this for most of these particle effects here, was using Krakatoa and Frost. And we didn't have to use Krakatoa. Krakatoa's got a really simple system of attaching its particles to a kind of volume, a volume filler, and it was just much simpler to kind of use that than go into P-Flow and or thinking particles and do it that way. So again, it's just finding, once you know a little bit about each piece of software, I think that's kind of the point to what I'm trying to kind of portray over the next few days, and just knowing a little bit about what the parameters are of everything. Gives you a huge array of tools to then do whatever you want for a project. And once you know the basics, it's very easy to then go into detail and learn more about a certain technique if a project warrants it. But if you don't have that kind of library of knowledge in your arsenal, then you won't have that base to start with and do anything new or challenging for any of your projects. So let's have a look at the TP transformation technique, and again, you'll be quite surprised at how easy this is. So if we go to our other scene and have a look at what we're doing. So just on a couple of the elements, we didn't want to overuse this technique because we've used it quite a lot in the past. But essentially, what we've got here is, seemingly, anyway, we've got an object which kind of appears out of nowhere in a kind of nice, kind of fractured, particly way. And the way that that's created is simply, which we'll illustrate in a new folder if it will work. So let's try it with our classic teapot, and we'll show some of the parameters we can play around with here. So let's have two objects. It doesn't matter about the resolution of this object. That's the great thing. The resolution of this object doesn't really matter in this system, but let's try and transform this teapot into this tube. So first thing we want to do, we want to create a new master dynamic set. We want to go to our conditions, our operators. We want to go to a fragmenter and add a blurb. And again, waiting for a project that merits it, but the way that Thinking Particles links with Rayfire works really well. I don't know if any of you have seen The Witcher 2, not the latest one, the one they did last year, game trailer on the frozen boat. That was all made in Thinking Particles and Rayfire, the way that fragmented, and they controlled it. They controlled everything through Thinking Particles, and they used Rayfire as the fragmenter. So what can we do with this blurb? We need to add our object, so let's pick our teapot, and let's pick our tube here. So it's very simple. We just click on our blurb to see our parameters. We know that we need to pick some objects for it to work with. And then just for the sake of working, let's just hide now our objects. So you can see here we've got these things displayed, but what we need to do is show the mesh. So we need to go to our master dynamic set, and we need to show that mesh. Nothing's animating just yet. but you'll see that what happens when we move this, if we turn edit on the fly off and we show our mesh there, what should happen when we select our blurb is that we can literally very easily with this one data operator within thinking particles transform from one object to another. And you can see how you could use that in any kind of project which merited a bit more creative animation. And it's really tempting. It was really tempting for us to use this quite a lot. But we felt like we'd done that quite a lot in the Golden Age film. So we wanted to kind of develop a few more techniques to not be a one-trick pony, basically. So in Jonah, we pushed the kind of R&D of particle systems a lot more. But this is a really great starting point to have some fun with this. And all this is animatable. So I'm going to go through some of the settings in here. First of all, it's good to just do a test at the mid-range and just see how your object's fragmenting. And you have a few different options with this. You have a few options on how to where it's fragmenting to. So by default, it will start on the top of one object and it will kind of materialize from the bottom up. So it's going from top down to bottom up, and we can see that here. So top down, but we can change this to like left or right, and you can see that it will kind of like animate in a slightly different way. And you can see that because it's kind of giving you a kind of path which represents roughly where the kind of things are going to go. So we can kind of build it top down to left to right. We have quite a lot of control over how this is animating. We can kind of play around with delaying and offsetting the in and outs and kind of the curves that these things are kind of animating across. But then we can also add detail to our simulation. By default, I tend to use count, and then I just kind of up this until I'm happy with the kind of level of detail that I'm getting within my mesh. And if we just go to 0 here and on frame 100 on 1, then we can have, we don't have to go back to the top, we can just scroll in our viewport if we ever put auto key on, that is. So now we can just see here what's happening when we animate. And then we can kind of add more to this. I think it needs to be a considerable amount more if you want to kind of fine details. Okay, let's do this. Jeff's going to have a fun time editing all of this, I think. I think I've given him the most headaches. Build me a better computer. Okay. Entitled recover. Let's see if we've got anything to recover from there. No. Luckily for us, this is super simple to set up. Okay. Particle systems, thinking, bang, properties. Teapot, pyramid, let's mix it up. Must have done mix that. Keep turning that off by accident. So go to here, operators, fragmenter, burp. Pick our teapot, pick our thing, and it changes the order of things depending on which one you pick first. Regarding this spline, let's just actually get this working again before we talk too much. So let's put our mesh on. Let's turn off edit on the fly and show our mesh. And then let's go to our blurb and let's animate it from 0 to 100 or 1. And we created the same effect. Let's not go too far with our count. Put them on 200 for now. You can see it kind of automatically shells everything. So it doesn't just keep it at single faces, it automatically kind of shells your particles, and you can kind of control that here with your kind of like shell type. If we stick it on which it should be auto updating if we put edit on the fly on. Let's just have a quick look. Let's just have a quick look. What was that, sorry?
So the fragmentation thickness, not the remaining thickness.
Ah, sorry, I'm in the wrong place here. Sorry, yeah. So, okay, yeah. So the fragmentation thickness, my mistake, it should be there, but we need to turn off edit on the fly to see any results. So we can see the effect of that there. So we can kind of control the thickness of these meshes. Here. Probably want this to be a little bit more visible. The other thing to kind of take into consideration is the material properties of this, and how do we get material onto this? We can see that we've made our thickness of our remaining mesh ridiculous, or rather 0.01. Or rather 0. None. So we don't want to see our original meshes. We only want to see our built meshes if we have this on hollow, sorry, so we can see it when it's built and when it's built back there, but we don't want to see it solid all the time. It will just kind of want to see it kind of fragment away from the original object. Let me just turn off display elected faces. Okay, so that's quite a cool effect, but how do we get material on it? What we need to do within that same dynamic set, we have to create a new operator, and we can kind of rename this material. Within there, we want a shape material. And from there, we can then add any kind of material we want with any kind of mapping. If we activate Vray as our render engine. We can take this material, call it test. We can just click and drag it and put it in there. Whatever kind of settings we have within our mapping, and whatever we have as our UVs on our original object, will kind of appear on this on these particles. If you've got different operators within your master system, then you do need to kind of select which group you're using. Because there's only one, it's coming up as all, and then you have to link your particles to that there to say which operator you want to be affected by this material test. Now that's the way that we kind of do the material on here, but there is this also option called material mix mode, and what that's going to do is it's going to automatically show and render that material. However, the disadvantages of that is that when you have that selected, it only works single threaded, so it won't use all of your cores to then render these particles. I found out the hard way after waiting about 7 years for the beginning of the golden age to render before I actually figured that out. So this material checkbox is will give you that kind of like material animation between the two objects automatically. So let's unhide our objects that we had. So if these two had slightly different materials, then the material mix mode would give us a blend in the render. It doesn't show it in the viewport, but it would give us a blend in the render between those two colors, basically. And we can kind of animate our self mixed mode frames. This is essentially saying from which point to which point is that material animating, over how many frames. But we don't really use this. What we do is if we do have these two materials, we'll create a blend material, and then we'll simply have our green teapot and our blue material in here, and we'll manually animate from frame 0 to 100 that material, and then we'll plug that into the shape material instead. That gives us more control, and it allows all of our cores in our system to be able to render this, this animation. So let's give this onto our TP. And again, it won't display the color, but it will render the difference in colors, basically, once we can then hide our base objects. The other thing, what happens is when we move this object, is that it's going to automatically update where our thinking particles goes to, so we can kind of have a huge amount of control over where that is actually working. In terms of the curve, let's just hide this. The curve is generated through these tangents here. Let's just have a look at this. The out and the in tangent for each of the objects. So they'll have different settings, so you'll notice that these numbers change. So our teapot, it's not got an in tangent, so that's not going to change anything. It does have an out tangent, because that is kind of fragmenting away. So if we want a more direct, straight linear effect, we can kind of click on our pyramid, and then that does have an in tangent, so we can change that. And we change them both down to 0, and we create an effect which is kind of more linear and straight. So these are a few different techniques that we've used for Jonah. Hopefully this gives you kind of a broad range of the kind of animation types that we use. Again, it's knowing a little bit about each one so that you can kind of use it effectively within your projects. And I think unless we'll take any questions on anything we've covered today, in fact, we'll leave it at that. How are we doing? Are we all still alive? Again, like I think today it's been good in the sense that we've been able to kind of problem solve a few of the kind of issues we came into. We were thrown a little bit by the loss of my track shot this morning, so hopefully you can all forgive me for that. And hopefully we've kind of gone through and resolved that shot to enough detail that we can kind of understand how we can track a shot which has a lot of native problems within it. And then this afternoon, again, it's just kind of like understanding each of the kind of animation plugins and systems that we use, and which is again very different for each project. But hopefully, I've introduced you to the basics of each of those elements, so that you can go off into your own projects and at least have more of an idea of what's possible very quickly within some of the animation techniques that we've used. So, yeah, are there any questions online or anything? Cool. All right. So tomorrow, we're going to be covering the rendering and compositing of a number of elements. We're going to be talking about basic, or rather basic but sometimes less obvious render settings for rendering animations, specifically for static, simple moving objects and dynamic moving object scenes. We're going to be talking about the composition within Nuke of some of the elements for the street scene that we've been covering for the animation today. We're going to be going through a professional Nuke workflow setup for animation, but also a recent development we've started for doing the development of still images and the benefits of that. So we're going to have a good composite and render day tomorrow, so hopefully we can look forward to that.